Before we begin this session, let me first draw your attention to the disclaimer slide. All the images that I have used in this presentation or video are AI generated images. These images are not taken from any real computer systems, company browsers, or even the hardware manual. They are created to represent the ideas visually. And why I'm mentioning this? Because many things that happen inside a computer during the startup cannot be seen in real life. We cannot open a running computer and watch the kernel loading or the bootloader working. So these images act like a visual imagination tools. They help us understand what is happening internally. I'm not claiming ownership of these images too. They are used only for learning and explanation, nothing else. With this clarity, let us now move to the actual topic. Now that the system has completed its hardware check, which we talked in earlier session about post, power on self-test, an important question arises. And this question is asked by computer to itself. Where is the operating system? Up to this point, the system has only checked hardware. It knows processor is working. It knows memory is available. It knows storage devices are connected. But it has not started the operating system. So now the system reaches to a very important decision point. It must locate where the operating system is stored. This could be on hard disk, SSD, or even a USB drive. And if not, probably over a network in some system. And this step decides the future of the startup process. If the system cannot find the operating system, it cannot move forward. You definitely can relate this to programming. Imagine writing a program that depends on a file. And if the file path is wrong, the program cannot continue. In the similar way, if a system cannot find the OS location, the startup process stops. So it is helping, this particular slide is helping us to understand that finding OS is not automatic. It is a planned and guided process. Now, let us talk about an older but very important concept, something known as MBR, Master Boot Record, which stands for, like MBR stands for Master Boot Record. This method has been used since the early days of personal computers from 1980s. MBR stores startup related information at the very first part of the disk. Think of it like the first page of the book. Before reading the full book, you generally look at the first page to know what it contains. In the same way, the system reads the first part of the disk to know how to start. However, MBR has some limitations. It supports storage only up to 2 terabytes. It allows only 4 primary partitions. And because of these limits, MBR is the only mostly used in older systems today. Still, you may find it on older computers, laptops, some USB drives, or even the legacy systems. Now, what it helped us? It helped us to understand why technology keeps changing. The older solutions work, but only up to one point. So to overcome the limits of MBR, a modern solution was introduced. And this solution is called a GPT or GUID partition table. GPT is part of the UEFI standard. Unlike MBR, GPT supports very large storage devices, much larger than 2 terabytes. It also allows many disk partitions without strict limits. Another important feature of GPT is safety. GPT stores backup copies of the partition information. So even if one part gets damaged, recovery is possible. And this makes GPT more reliable. Modern operating systems, especially the newer versions of Windows, require GPT when using UEFI. You can relate this to software versions. Older software works for small needs. So as need grow, the new designs are required. And GPT is simply a better design for modern systems. Now, once the system knows where the operating system is stored, it loads a small but very important program. And this program is called as bootloader. This bootloader has only one job: find the operating system and start it. That is why it is called as gatekeeper. Different operating systems use different bootloaders. For Windows, we have Windows Boot Manager, which controls how Windows starts. Further, it provides recovery options too. For Linux, we commonly use grub, that is GNU Grand Unified Bootloader. Grub allows selecting between multiple operating systems. And this is why it is popular on dual boot systems. Similarly, for Mac OS, Apple provides its own boot manager, tightly integrated with its hardware. The key idea here is very simple. The bootloader acts as a bridge between firmware and the operating system. Without the bootloader, the operating system cannot be launched. So in many systems, more than one operating system is installed. For example, Windows and Linux on the same machine, multiple Linux distributions on the same machine, even recovery environments are available on the same machine. In all such cases, the bootloader displays a menu at the startup, and this menu allows the user to choose which operating system to load. Once the user makes the choice, the bootloader loads the selected operating system. So now we understood that bootloaders are providing us flexibility. They allows multiple systems to coexist. And this is very, very important concept in system administration and advanced computing setups. Now, after bootloader finishes its work, the most important part of the operating system is loaded. And this part is called as kernel. Kernel is the core of operating system. It acts as the main controller of the system. Everything passes through the kernel. Programs do not directly talk to hardware, they talk to kernel. The kernel then talks to hardware. You can think of this kernel as a manager. Applications make requests. The kernel decides how and when those requests are going to get handled. And without the kernel, the operating system cannot run or cannot function. So let us try to understand now what are the key responsibilities. First, it acts as a CPU manager. It decides which program gets processor time. Second, it works as a memory controller. It decides how RAM is shared among applications. It provides or acts as a hardware bridge by providing a common way for devices to communicate. It enforces security. It keeps programs separate so that one program does not harm the other. It also coordinates the storage operations. Reading and writing files happens through the kernel. The kernel is loaded in RAM so that it can respond very quickly. Because of this, it can handle thousands of requests every second. So we understood now why the kernel is heart of the operating system. Once the kernel is loaded in memory, it starts to do its work. It follows a fixed sequence of steps. First, it loads the device drivers. Drivers allow the hardware to communicate with the system. Next, it starts important system processes. And these processes support all other applications. Then it sets up the memory usage. It ensures that programs use memory safely. Finally, the system files and settings are prepared. At this stage, the system is ready for user programs. And this marks the end of boot process. The computer is now fully awake and ready to do the work. So what we studied today is the journey of computer from power on to ready state. We saw how the system finds the OS, uses boot records, loads the bootloader, starts the kernel, and prepares the system. And this understanding will help us to see computers not as a magic boxes, but as well designed systems. And this will help us in operating system troubleshooting and real world computing problems. Thank you.